In the light of fast development of cyber threats, the complexity of heterogeneous ICT ecosystems raise major security concerns. In this regard, Bieco provides a set of tools and methodologies for building trust with respect to malicious attacks that can endanger the safety of a system and of the ecosystem. More specifically, Bieco provides various mechanisms for malicious failure prediction and trust assurance, considering the design time and runtime phase of a system. These mechanisms are instrumented by an online framework that connects various methods and tools. Even though the approaches are general, for being more specific in explanations, we exemplify the execution of Bieco within a robotic use case. The Research Consortium, funded by the European Commission, through the Research and Innovation Programme, is composed of 11 partners, from 7 European countries: Portugal, Italy, Romania, Austria, Spain, Poland, and Germany. For the design time phase, we will start with the context establishment, continue to the risk identification step, further on the security testing and security assessment that result into the labeling phase. For runtime, we present the auditing setup, creation of digital twins, the finalization of the well-defined rules, followed by the execution of the auditing framework. The user interface provides access to both users and tool developers, in order to be able to define, control the status and interact with specific tools. Tools are defined in a similar fashion as microservices, with asynchronous access, multitasking and loose coupling. So, they are able to connect to the platform, receive and send data for specific jobs. We define jobs as a collection of steps that need to be executed in order to provide some results to the user. One or more tools can be defined in each step, so they can be executed either in parallel or sequentially. This accommodates both the runtime and design time methodologies, in an abstract, extendable and loosely coupled way. The Bieco platform has two main components, the UI and the orchestrator, components that cooperate and respond to user requests. Tools can be defined in the Tools section by tool developers. They can define different aspects, like endpoint, access tokens, inputs, and also enable or disable the tool. Services is the section that provides an overview of the connected tools and their state. This page is continuously refreshed in order to retrieve the latest statuses. If any of the used tools for a methodology is not online, the platform will not be able to execute a specific job. Different projects for a user are defined as jobs, since they can be executed by a user. Defining a job is easy, providing a name and description. Other information and settings will be defined as the project progresses. The job view has a direct connection with the UI and orchestrator via a WebSocket connection. Any failure in the Bieco platform will be immediately announced to the user. The job status can be assessed from the overview, along with the last execution timestamp. The history table provides useful information about the last execution of the job with relevant events and results. This table can be downloaded in CSV format, for offline use. The two methodologies, runtime and design time, have their own tabs, with specific interfaces for both. Interaction with the tool UIs can be done via specific buttons. Each methodology provides its own possible actions, steps and results. The job execution does not stop when closing the browser window. It is possible to close it and come back later for the results.